Okay guys, in this video we're going to learn how to identify quadratic functions. And what a quadratic function is that it can be written in the form of y equals ax squared plus bx plus c. Now what's really important here is that a and c must be real numbers. And a cannot be equal to 0. Okay? So I'm going to show you a couple examples of what is not. Alright, so we have y equals ax squared plus bx plus c. Now y equals x squared plus x plus 1 satisfies this. A is not 0. Y equals x squared plus 2 satisfies it also. A is not 0 and c is a real number. And also y equals x squared. It's really important that a cannot equal 0. As long as a is a number other than 0, it's most likely a quadratic function. Okay, now some examples that aren't quadratic functions are y equals x plus 1. Since we're missing the x squared, then this is considered a linear function. So it's not a quadratic. Y equals 2, no. Y equals 2x, no. It's missing it's missing our x squared, which in this case will be 0, 0, and 0. So it doesn't satisfy it being a quadratic function. Now, simply by looking at the equations, you could tell which ones are quadratic and which is not. Now, if you're trying to figure it out by just looking at the table, one thing that you're able to do is find a constant difference in x values, and also find a constant change in the second difference of y values. Now, to show you that, I'm going to try and show you here. I already created some functions. Now, right here, we have y equals x squared plus 1. Now, looking at it, we could just tell it is a quadratic function, so it is. Now, we're going to try and look at some of its values. So we have negative 2, negative 1, 0, 1, and 2 for the x. Y values, we have 5, 2, 1, 2, 5. Now, we're going to look for the constant change in the x values. So right here we have positive 1, positive 1, positive 1, positive 1. So our first step here is satisfied. Now to check the second difference of y values, we gotta look at our y's. So 5 and 2, difference there should be negative 3. Right here should be a negative 1. Right here is a positive 1. And right here is a positive 3. So then right here, that's our first difference. Second difference, we have negative 3 minus a negative 1, which would be a negative 2. Negative 1 minus 1 will be a 2. Oh, will be a positive 2. Sorry. Positive 2. Negative 1 minus 3 should be positive 2. And right here we have 3 minus 1 will be a positive 2. Okay, so we have a constant change in our second difference of y values, meaning that this is a quadratic function just like we showed over here. Okay, now let's do this one. So we have y equals negative 2x squared. A is not 0, but what we have here, so it's a quadratic function. Now we can start checking our table values just to double check. Now if you're just given a table, you should use finding the difference in x values and the second difference of y values to identify whether the table is a quadratic function. Okay. Now we have negative 1 and 2. Negative 1 and negative 2. The kind of difference there would be a positive 1. Right here is a positive 1. See as our values here are increasing by 1. So we have positive 1, positive 1. So constant change in x values is done. So let's see here. So here will be a negative 2 minus negative 8, which should be a positive 6. 0 minus a negative 2, positive 2. Negative 2 minus 0 will be a negative 2. Negative 8 minus a negative 2 will be a negative 6. Constant change here will be a negative 4. Constant change here, negative 2 minus 2 will be negative 4. Negative 6 minus a negative 2 would be a negative 4. So we have a constant change in our second difference of x values and also first values. So meaning that this is a quadratic function. Okay? Now, let's do an example of what's not a quadratic function. Now, you're given this table, you can tell it's a linear function because it doesn't have, or x squared doesn't satisfy what we're trying to look for. Now, double check if you're just given the table of it, and if you're not given this. So let's go ahead and check here. First, we check our x values. So we have a negative 1 minus a negative 2, which will be a positive 1, positive 1, positive 1, 2 minus 1, positive 1. Now our constant change in x values is satisfied. So right here we have a 1 minus 0, which will be 1, 2 minus 1, 1. Right here we have 3 minus 2, 1, 4 minus 1, 4 minus 3, 1. Okay. Now 1 minus 0, 0, 0, 0. Okay. Now here we don't have any values in for our, we don't have any more values for our y value because they're not changing. Okay, they're changing in our, there's a constant change in our first difference, but there isn't a constant change in our y value. Even though it's 0, there's no number that's actually being there, any positive or negative number. It's just 0, so that means it's not changing. Okay, so you get here, it is not a quadratic function. Okay. Now, I want you to focus on these two. Okay? Now, this is the next step for us. Okay. Alright. Now, we're going to use these tables that were given to us, and we're going to try and graph our equation. Now, for our first one, I have the plots already pointed. So we have negative 2 and 5. Negative 1 and 2, 0 and 1, and 1 and 2, and 2 and 5. Now each value here for our x-axis is a value of 1. Our y value should be a value of 1 also. Okay, so 0, negative 2 and 5, negative 1 and 2, 0, 1, 1 and 2, 2 and 5. Okay, now these points are going to help us to connect our parabola, and that's the name of the curve that we're going to create. Now this parabola will keep going. Okay, so it's going to look like that. Okay, hopefully you can see that. Now for our second graph, we're going to have, let's see if we could put this into our video. Fold this. So our second table, we have negative 2 and negative 8, negative 2, negative 8, negative 1, negative 2, 0, 0, 1, negative 2, and 2, negative 8. Okay, so our plots are pointed. Our points are plotted. Sorry. We start connecting our dots, and this function will keep going. Okay, these plots are just here. These points are just here to help us create our parabola, which is the curve that quadratic functions create. Okay, so this is parabola, kind of like a happy face, and this is like a sad face. Okay, now next step in this one, in our video, is that we're going to have to deal with a vertex, domain, and range. Now what vertex is the highest or lowest point of our parabola. Now if you notice here, our lowest point would be 0, 1. And our highest point here, this highest point will be defined as the highest point here in this parabola, in our second parabola. Kind of like a mountain here. So whenever you see a mountain-shaped parabola, then it's most likely going to have a maximum, a vertex of maximum. Okay. Now, highest and lowest point of a parabola. The highest will be considered a maximum. Lowest will be considered a minimum. So then, okay. So a vertex, highest and lowest point of a parabola. So we're going to find our vertex for the first one. So highest point here in our parabola will be 0, 1. And our vertex for our second parabola here will be 0, 0 at the origin. 0, 0. Okay. Now, let's see. Opens upward or opens downward? Opens upward or opens downward? Now, what you should notice here is that our parabola here creates a happy face. Okay? So whenever it creates a happy face, that means our parabola is going to open upward. Okay? Now, the reason it opens upward is because our a value here, like we had in our equation, is greater than 0. Okay, so that means it's a positive number. So positive number, that means it's a positive happy face, and it's just a quick way of remembering. Whether it opens upward or downward. So whenever it opens upward, then think of it as a positive a value or a positive face. Now, for the other one, we have a sad face. So we have a positive face over here. This one will mean that we have a negative number. So we have a minus 0, a less than 0, which would mean a is less than 0. So that means that we have a negative a. Like right here, we have a y equals negative 2x squared. So we're going to have a negative face or a sad face. Here, in our equation over here, we had a y equals x squared plus 1. And we have a positive value here for a. So we have a happy face. Okay, so this one opens downward. Alright. Now, since this one opens downward, our happy face opens downward, think of it as the site between two mountains. So we have a mountain here, and we have a mountain here. This will be considered the minimum, the lowest point of between two mountains. Okay? Now, right here, since it's our minimum point, that means it's our lowest point in our parabola. So our min would be here. And our value here will be y is greater than equal to 1. Okay. Now, whenever we reference our minimum or maximum, then it's always going to look at the y-axis. Always look at the y-axis. Okay. So y-axis here is 1, and right here is our value 1. So it's going to be right here. Oh, actually, my mistake. This is going to go down for our range. Okay. All right. Now, let's look at our next equation. So we have our sad face. Now our sad face, you notice how it looks just like a mountain. Then, as a mountain, it has the highest point. Okay, and so that's going to be considered a maximum there. Now, domain and range, maximum. Okay, so I just want to specify that for maximum and minimum. Okay, now, sorry for this. Now what I want to talk about is domain of a quadratic function. And it's just primarily all the x values within the function. And whenever you deal with a quadratic function, you're most likely going to deal with a all real numbers case, unless you're given a specific case, unless you're given a specific set of numbers. Now the domain here, since just go ahead and run over your line, run over the pencil across the equation like this, then you notice that all of our x values are there present. Okay. Now, what I mean by that is that we're going along the x-axis, so that means we're touching all of our x values. So right here, it's going to be a set of all real numbers that we're touching. So, all real numbers. Now our range here, what I was putting earlier, starts at our vertex. Now, since we have a minimum, that means our y value here for our vertex is the minimum value that we can have. So we have 1 less than equal to y, because the range deals with all the y values in the function, meaning that our range begins at the minimum or maximum value of the function. So we have here in our vertex. So we have y is greater than, all the y values are greater than equal to 1. Okay, just like we have here. Okay, so just kind of just run along the y-axis like this, and it doesn't start, and then we hit it right there. That's where the 1 starts, and then everything else there, you see our pencil is touching the line, and it just keeps touching it, and meaning that all the y values are being touched. Okay. So this will be it for that problem. Now our next one, sorry, let me just fold this. Now our next one, we have a domain. Okay, so our domain here will be running along a pencil. Our pencil is touching the equation. Pencil's touching the equation. It's still touching it, still touching it. Keeps going, and then over here is just infinite. The graph still keeps going. It's just I ran out of paper after I ran out of room. So right here will be all real numbers. Now our range. Now remember, our range starts at our vertex. Okay, or starts at our vertex, and we have a mosquito. Okay, so our range starts at our minimum or maximum of the function, and then we have our maximum here. Now go ahead and run along the pencil down the y-axis, and then it's not touching it, and it starts at 0. Okay, so 0 is our greatest. 0 is our greatest value that we have, so it will be 0. Now everything here, we start hitting all the negative values of y. Okay. So that means that 0 greater than or equal to y. Okay, or you could just write it as y is less than or equal to 0. Okay, so meaning all the y values are less than or equal to 0. Since they're going all the way down here, since all these values down here are less than 0 for our y-axis. Okay, now that's primarily it for this lesson. For this video. There might be other videos being uploaded and covering section 1 and 2. And I'll see you in the next video. Hopefully this helped out a lot. Alright?